Food traceability systems use uCode tags assigned to food packages. We record who produced the package, when, and how it is transported, and over which route, as well as additional information, such as the type and amount of agrochemicals used during the growth of vegetable and fruits. Such traceability information is useful when a food incident occurs. By performing the process of backtracing, we can home in on the cause of the incident. In Japan, prototypes for such food traceability systems have been tested with the cooperation of many farmers, agricultural cooperatives, distributors, wholesalers, markets, and retailers. Using active sensors, we can continuously monitor the temperature of the food package during transport. In a futuristic scenario, we may one day have refrigerators that warn us of stale foods inside by reading the information on each product. Similar traceability systems can be built for other goods, including medical drugs. In this prototype system, uCode tags are used for medical applications. The system checks whether the drugs are dispensed correctly at the pharmacy, according to the doctor's prescription. It can also check drugs that are known to have caused undesirable effects on the patient before, using the patient's individual medical record stored in an IC card. At home, similar systems can warn us when someone is going to take a bad combination of drugs, or a bad combination of drugs and foods. uCode tags can be used for positioning. Unlike GPS, uCode tags can indicate current position with an error of only a few centimeters, even underground or inside buildings. uCode tags offer pinpoint accuracy that GPS can't deliver, which is essential for pedestrian guidance. To illustrate just one application, let's look at how uCodes can offer route guidance to the visually challenged.
Fork. Go left. You are near the south side of the Faculty of Engineering Building 11.
Systems like these can help virtually anybody. They can assist the physically challenged, provide information for shoppers and sightseers, and give multilingual support to overseas tourists. The information can even be tailored to the user's precise time and location. For example, railway operation information can be automatically delivered from the railway company's server when commuters approach railway stations. Since 2002, numerous prototype services based on universal design have been installed in locations throughout Japan, including Tokyo, Kobe, and Nara. These systems are already in practical use every day in Japan. At Ueno Zoo, a system offers explanations of each animal to visitors. Another at Hamarikyu Gardens provides historical information and sightseeing guidance. In Japan, a fire alarm must be installed in every home by law. This system, operated by the Center for Better Living, uses uCodes for fire alarm maintenance. Tags are attached to the fire alarm units when they are shipped from factories. During installation, the system records who installed the fire alarm, as well as the time, date, and place of installation. The system notifies the center when batteries need replacing, and sends out a request for recall if a manufacturing problem is found. Already about 2 million fire alarm units in Japan have been shipped with uCode tags. The National Geospatial Information Authority of Japan plans to attach uCodes to survey reference points. By using uCode tags to provide additional information about reference points it had previously measured, the government agency expects to lower the cost of third-party survey efforts. Other applications are just beginning, such as placing uCode tags on lampposts and other public facilities to provide sightseeing guidance. Applications in public facility management are already in use. Ubiquitous computing has taken root in Japan through numerous applications. Though the first applications were limited in extent and narrow in scope, 2010 has seen a greater number of exciting applications, adding value to public infrastructure. As you can see, both the feasibility studies and commercialization have come a long way. Forecasts indicate that by 2015, commercial and public applications will be virtually everywhere.